Ay, no, me paro. Sí, bebé. Qué bello.
Mamá, el recogedor lo has visto.
¿La cocina?
Ya buscaba allí.
Property of solves represents 2.1 Systems of linear equations. Chapter 5 Matrix. Vector calculus, group, system of linear equations, vector space, linear affine, solved by, mapping, matrix, inverse, Gaussian, elimination, chapter 3 analytic geometry, 19, vector, closure, abelian, with mass, linear, independence, maximal set, basis, chapter 12 classification, chapter 10 dimensionality reduction, resources are Gilbert Strang's linear algebra course admit and the linear algebra series by 3 Blue no Brown. Linear algebra plays an important role in machine learning and general mathematics. The concepts introduced in this chapter are further expanded to include the idea of geometry in chapter 3. In chapter 5, we will discuss vector calculus, where a principled knowledge of matrix operations is essential. In chapter 10, we will use projections, to be introduced in section 3.8, for dimensionality reduction with principal component analysis. PCA. In chapter 9, we will discuss linear regression, where linear algebra plays a central role for solving least squares problems. 2.1 Systems of linear equations. Systems of linear equations play a central part of linear algebra. Many problems can be formulated as systems of linear equations, and linear algebra gives us the tools for solving them. Example 2.1 A company produces products N1, Nn for which resources R1, Rm are required. To produce a unit of product Nj, I If units of resource are needed, where igual a 1, m and j igual a 1, n the objective is to find an optimal production plan, i.e., a plan of how many units xj of product nj would be produced if a total of b units of resource are available and, ideally, no resources are left over. If we produce x1, xn units of the corresponding products, we need. Derechos de autor 2024 MP Eisenroth, A. Faisal, C.S. Ong. Published by Cambridge University Press, 2000. 2020. Figure 2.2 A mind map of the concepts introduced in this chapter, along
along with where they are used in other parts of the book, represents, composes, 20 linear algebra a total of I1 times 1 plus ANX. 2.2, Manayunid soft resource re an optimal production plan, x1, xn, rn, therefore, has to satisfy the following system of equations, a11 times 1 plus a1 nxn equals b1 m1 times 1 plus amxn equals bm. 2.3, where age rand equation. 2.3, is the general form of a system of linear equations, and system of linear equations x1,
Remark geometry interpretation of system of linear equations. In a system of linear equation with two variables, s1 and s2 is linear equation define a line of the s1, s2 plane. Since a solution to a system of linear equation must satisfy all equations simultaneously, the solution set is the intersection of these lines. This intersection set can be a line in the linear equation describe the same line, a point or empty when the lines are parallel. An illustration if given in figures 2.3 for the system 4s1 plus 4s2 equal 5. 2s1 minus 4s2 equal 1. Okay, 4s1 plus 4s2 equal 5. 2s1 plus minus 4s2 equal 1. Where the solution space is the point S1 is 2. 1 point similarly for three variables each linear equation determines a plane in 3 dimensions space when we intersect the planes satisfy a linear equation at the same time. We can obtain solutions set that is a plane, a line, a point, or empty when the planes have no common intersection. For a systematic approach to solving system of linear equation, we will introduce a useful compact notation. We collect the coefficients aia into vectors and collect the vectors into matrices. In other words, we write the system from 2.3 in the following form.
Esto está sucio, todo esto está sucio.
22 Linear Algebra 11. A 1n and 1. Am x1xn equals b1bm. 2.10. In the following, we will have a close look at the symmetrices and fn computation rules. We will return to solving linear equations in section 2.3. 2.2 Matrices Matrices play a central role in linear algebra. They can be said to compactly represent systems of linear equations, but they also represent linear functions, linear mappings, as we will see later in section 2.7. Before you discuss any of these interesting topics, Let us first define ta matrix isandwhatkindoFOPERATIONSWECAN. We will see more properties of matrices in chapter 4. Definition 2.1. Matrix with m. N real valued. M. N. Matrix ACE matrix ANM. N to for element sage. I equals 1. M. J equals 1. N. Which is ordered ACCORDINGTOARECTANGULARSCHEMECA equals 11 a 12, a 1n a 21 a 22, a 2n and 1 am2, Aja, 2.11, by convention, 1, n, matrice Essericaled and, m, 1, matrice Essericaled row columns this a special matrice